Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on reading scales. If you need any extra help on reading scales, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 284, there's a dedicated video tutorial there on reading scales. Alternatively, you can scan this QR code. In this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says Martha is buying carrots, so she's buying carrots, and the scale shows the amount she buys. And we've got this scale, and it's in kilograms, and it goes 0, 2, and 4, and the arrow is pointing here. And part A says, what amount of carrots does she buy? So we need to know what this number is here. So if we have a look at it, we've got 0, 2, 4. Well, each of these bigger lines is 1. It's going 0, 1, 2, then that would be 3 there, and then 4. So that's 3 kilograms. So how much carrots does Martha buy? The answer would be 3 kilograms. Okay, if we have a look at part B. Part B says Martha can use the scale to weigh 6 kilograms of apples. Explain how she can do this. So how can she use this scale to measure 6 kilograms of apples? There's a few approaches she could use. She could measure out 3 kilograms of apples and then another 3 kilograms of apples. She could measure 4 kilograms of apples and then 2 kilograms of apples. She could even do 6 lots of 1 kilogram of apples, and then altogether that would be 6 kilograms as well. So let's explain one of those. And that's it. I've just explained that Martha could measure 4 kilograms and then 2 kilograms of apples, and then altogether she'd have 6 kilograms of apples. Okay, let's look at our next question, question number 2. So question number 2 says the diagram shows the speed a car is travelling. So we've got the speedometer, and it's in kilometers per hour, and it goes from 0 all the way around to 100 kilometers per hour. So let's have a look at this. So the arrow here, it's exactly in the middle of 60 kilometers per hour and 70 kilometers per hour. So that means that this would be 65 kilometers per hour because it's in the middle of 60 and 70. So that's the speed the car is traveling, 65 kilometers per hour. And if we go down to part A says what speed is the car traveling? The answer is 65 kilometers per hour. And to do that, I just noticed that the arrow or the needle is exactly halfway between 60 and 70. Now there is another way to do this question, that's to work out what each of the little lines is worth. So to get from 0 to 10, there's 1, 2, 3, 4. So 10 divided by 4 is 2.5, so it'll be 2.5, 5, 7.5, 10, and so on. So if this is 60, that'll be 62.5, and then that'll be 65. But I think a much easier way to do this question is just to notice that that arrow or that needle is exactly halfway between 60 and 70. So it's going to be 65 kilometers per hour. Okay, then part B. Part B says the speed limit on the road is 80 kilometers per hour. And we've in part B been asked to work out how many kilometers per hour slower than the speed limit is the car travelling. So the speed limit is 80 kilometers per hour and the car is travelling at 65 kilometers per hour. So if we take them away, we'll find out how much slower than the speed limit the car is travelling. And 80 take away 65 is 15. So the car is going 15 kilometers per hour below the speed limit. Okay, let's look at our next question, question number 3. So question number 3, we've got a series of scales and we need to write down the value that the arrow is pointing to on each of the scales. So here we've got 90 and 110. So let's work out what each of these little lines is worth. So to get from 90 to 110, it's getting bigger by 20. So we've got 20 and we're going to divide it by 1, 2, 3, 4. And 20 divided by 4 is equal to 5. So that means that this would be 95 and then that would be 100. Then that'll be 105, and then that's 110. Some people actually just look at it and say, well, we're not getting bigger by 10 each time, so is it 5? So it's 95, 100, 105, and then 110. So this is 105, and that's it. Okay, let's look at our next one, part B. So part B, we've now got this scale with 0 and 18, and we've got the arrow pointing here. So let's do it by inspection again. So well, is it 1s? 1, 2, 3, 4, 5, 6? No. Is it 2s? 2, 4, 6, 8, 10, 12? Not quite. Is it 3s? 3, 6, 9, 12, 15, 18. Yeah, it's getting bigger by 3 each time. So that means that this would be 3, this would be 6, 9, 12, and 15. And that means that the arrow is pointing to the number 6. So the answer is 6. Another way to do it is to say, well, to get from 0 to 18, altogether it's going to be bigger by 18 in 1, 2, 3, 4, 5, 6 steps. 18 divided by 6 is 3, so it's getting bigger by 3 each time. Okay, let's have a look at our next part, part C. So part C, we've got 3 here and 4 here, and we want to know what this arrow is pointing to. Well, it's not getting bigger by 1s, obviously, because it'll be 3, 4. So there's going to be decimals that's getting bigger by each time. So let's try 0.1s and see if that works. So 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and then 4. So it is getting bigger by 0.1 each time. So that means the arrow is pointing to 3.6. And that's it. Again, you can say to get from 3 to 4, it's getting bigger by 1, and there's 10 steps, so 1 divided by 10 is 0.1, so it's getting bigger by 0.1 each time. Okay, let's look at our next part, part D. So part D, we've got 8 here and 10 here, and we want to know what this arrow is pointing to, so what number this is. So is it 0.1? So 8, 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9, 9. So that's not 10, so it's not 0.1. So let's try 0.2. So is it 0.2? So 8.2, 8.4, 8.6, 8.8, 9, 9.2, 9.4, 9.6, 9.8, and then it'll be 10. So that's right, so 9.6, and that's it. Okay, let's look at our next question. So question number 4, we've got this thermometer and we've got the temperature here, and part A says write down the temperature shown on the thermometer above. So let's have a look. It's in degrees Celsius and we want to know what this number here is. So let's have a look at the scale. So here we've got 0 and 10. So is it 1? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's 1 each time. So that means in the middle will be 15, 16, 17, 18. So that's 18 degrees Celsius. Okay, so let's have a look at our next part, part B. So part B, we've got the thermometer and we've been asked to show a temperature of -6 degrees Celsius on the thermometer. Well, let's start with 0. So then this would be, well, this would be -5 here. And then remember, we're going down here. So this number here would be -6 there. So that's -6 there. So to show this on the thermometer, we'd shade that in all the way to this point here. So we're going to shade in all the way to -6. So that's a -6 there. And that's it. So that's -6. So we've shown the temperature of -6 on the thermometer by shading it up to -6. Now some students go here to this one, but that's a -4. Just be careful, obviously, where -6 would be and -4 would be. So that's a -6 there. And that's it. And by showing it, you just needed to shade in up to that -6 line there. Okay, let's have a look at the next question, question number 5. So question number 5, we've got the speedometer again, and we've got 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 miles per hour. And we've just been asked to write down the speed shown. So we've got 0 and 10, so it's not 1, so it's not going to be 1, 2, 3, 4, 5, that's 10. Is it 2s? 2, 4, 6, 8, 10. Yeah, so each time it's getting bigger by 2. So that means that's going to be 52, and this number will be 54. So that's 54 miles per hour, 54 miles per hour. And that's the speed shown on that speedometer. Okay, let's look at our next question, question number 6. Okay, let's look at our next question, question number 6. So question number 6 says, shown below is a thermometer. So we've got this thermometer and we've got the scale and it's in degrees Celsius. And we're told the temperature is -7 degrees Celsius. Well, it's not quite that today, but it feels like it at times. And we've been asked to show this temperature on the thermometer with an arrow. So where would -7 be? So we've got -6, -8. So -7 will be in the middle there. So that's it, -7. So that's the temperature of -7 degrees Celsius on the scale shown with an arrow. And that's it. Okay, let's look at our next question, question number 7. Okay, let's look at our next question, question number 7. So question number 7, we're told the speedometer shows the speed of a car travelling on a road. So this is the speedometer of a car, and it's got the units, miles per hour, and it goes from 0 all the way up to 160. Hopefully it's not travelling at that speed. And then we're told the car joins the motorway, and its speed increases by 25 miles per hour. What is the speed of the car travelling on the motorway? Okay, so let's find the speed of the car before it increases its speed by 25 miles per hour. So let's find this speed. Okay, so let's have a look at the scales. We've got 0 and 20. So if we went up in ones, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not right. So let's try 2s. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. So yeah, we're going up in 2s here. So in between 20 and 40 will be 30. So that's 30 there. And then 32, 34. So that's 34 miles per hour. So that's the speed of the car before it joins the motorway. And we're told that when it joins the motorway, it increases its speed by 25 miles per hour. So if we take the speed before it joins the motorway, 34, and then if we add 25 miles per hour to that, that'll tell us the speed of the car when it's travelling on the motorway. So 34 plus 25, well, that's going to be equal to 59. So that means that the car is travelling at 59 miles per hour when it's on the motorway. And that's it. So the speed of the car travelling on the motorway will be 59 miles per hour. So 59 miles per hour. And that's it. Okay, let's look at our next question, question number 8. So question number 8, we've got a thermometer again, and we've got this temperature. And part A says, write down the temperature shown on the thermometer. So let's find what we're going up in here. So we've got 0 and we've got 1, and it's not going up in 0.1s, because if it was going up in 0.1s, it'd be 0.1, 0.2, 0.3, 0.4, 0.5. So let's try 0.2s, 0.2, 0.4, 0.6, 0.8, 1. So yeah, it's gone up in 0.2s. So here, this is -2. We're going down another 0.2, so that'll be -2.2. So it's going to be -2.2 degrees Celsius. And let's just check that. -2.2, -2.4, -2.6, -2.8, and then -3. So that's it, yep. Okay, then we're told the temperature rises by 4 degrees Celsius. Work out the new temperature. So it was -2.2 degrees Celsius, and it's going to rise and go up by 4. So we need to add 4 onto -2.2. So if we add 2.2 on, if you've got -2.2, if you add 2.2, you get to 0. So for instance, if you've got -2.2, if you add 2.2, you get to 0. And altogether we're adding 4, so we need to add another 1.8. So if we add another 1.8, that'll be 4 altogether. So that'll be 1.8. And if you've got -2.2 and you add 4, you'll get to 1.8. And I like to think of it in terms of money. If my bank account said -£2.20 or -2.20, if I put £4 in, well, £2.20 would go back to the bank and that'll leave me with £1.80. So that'll be 1.8. And that's it. So the new temperature would be 1.8 degrees Celsius. Okay, let's look at our next question, question number 9. So question number 9, we've got this measuring jug, and we're told that Archie pours some milk into this measuring jug. So Archie's poured some milk into this measuring jug. This grey bit must be the milk. And we're told that he needs 650 millilitres for a recipe. And the question says, how much more milk does Archie need to pour into the measuring jug? So let's work out how much milk's in the measuring jug to begin with. So we've got 1,000 millilitres or 1 litre. So let's see what we've got up in here. So if it was 100 millilitres, it'd be 100, 200, 300, 400, 500. So it's not 100 millilitres. Let's try 200 millilitres. So it'd be 200, 400, 600, 800, and then 1,000. Or alternatively, we could take what this scale is, the 1,000 millilitres, and divide that by 1, 2, 3, 4, 5, and then we'll know that each step is 200 millilitres. So here we know that to begin with, Archie's poured 400 millilitres into the measuring jug, but he needs 650 millilitres altogether. So if we do 650, take away the 400 that he's got in there already, that'll tell us how much more he needs. So 650, take away 400 would be 250 millilitres. He needs another 250 millilitres. 200 millilitres would bring him to 600 millilitres, and then another 50 would be 650 millilitres. So how much more milk does Archie need to pour into the measuring jug? The answer is 250 millilitres. And that's it, 250 millilitres. Okay, let's look at our next question. Okay, so question number 10. Question number 10 says that Gregory is buying flour. So Gregory's buying flour, and the scales show how much flour Gregory buys. So this measurement here is how much flour Gregory buys. So let's figure out what this is. So we've got 0, and then we've got 2 kilograms, 4 kilograms, 6 kilograms, and 8 kilograms. So it's in between 4 and 6 kilograms. Well, let's work out what this number would be. So let's see what we're going up in each time. So if we go from 0 to 2 kilograms in 1, 2, 3, 4, 5 steps. So if we take the 2 kilograms and divide that by 5, that'll tell us what we're going up in each time. So we could take 2 and divide it by 5, do decimal point now 0. So how many 5s go into 2? 0 remainder 2. And how many 5s go into 20? That's 4. So that would be 0.4. So that means the scale each time we're going up by 0.4. So 0.4, 0.8, 1.2, 1.6, 2. 2.4, 2.8, 3.2, 3.6, 4, and so on. So each time it's getting bigger by 0.4 kilograms. So we need to figure out, if we look at the arrow or the needle, what's it pointing at? So we've got 4, 4.4, 4.8, 5.2, so that's 5.2 kilograms. So how much flour does Gregory buy in kilograms? The answer would be 5.2 kilograms, because that's 5.2 kilograms. You then have 5.6 and then 6, so 5.2 kilograms. And then part B. Part B, we're asked how much flour does Gregory buy in grams? So we need to change the 5.2 kilograms into grams. So remember, there's 1,000 grams in a kilogram, so that'll be 5,000, and then another 200 grams, that'll be 5,200 grams, or just multiply that by 1,000, means we would move the digits 3 columns to the left, so the 5 would move from the units of the ones column into the thousands column, the 2 would move from the tenths column into the hundreds column, and so on. So the answer would be 5,200 grams. Okay, let's look at our next question, question number 11. So question number 11, we're told, here's the fuel gauge for a lorry. So this is the fuel gauge for a lorry, and we've got 1/4, a half, 3/4 full. So that's quite straightforward. At the minute, it's 3/4 full. As you can see, the tank is 3/4 full. And the question says, when the fuel tank is full, it holds 400 litres. So when it's full, that's 400 litres. That's 400 litres there. And the question says how many litres of fuel are left in the tank. So we want to work out how many litres of fuel are left in the tank. So there's a few different ways you could do this. One approach is to use the fact that when it's full, that's 400 litres, and say, well, half full would be 210 litres. A quarter full would be 105 litres, so that's 105 litres. And then 3/4 full, if you add a quarter and a half, well, 210 plus 105 would be 315. So that'd be 315 litres, and that's it. So how many litres of fuel are left in the tank? The answer would be 315 litres. And what we done there was we found what half the tank would be, 210. We found a quarter of the tank, 105. We added them together because a half plus a quarter is 3/4. That'd be 315, and that's it. Another way to do it would be to say, well, if the tank is full, that's 420 litres. They've used a quarter of a tank, so a quarter of a tank is 105, because remember, half of it is 210, so a quarter of it's 105. And then if you take 105 away from 420, that's 315 as well, so 315. Alternatively, actually, whenever I'd done this question, what I'd done was I just worked out what 3/4 of 420 is. Because we know from the gauge that the tank is 3/4 full, so if we do 3/4 of 420, that'll tell us how many litres of fuel's in the tank. So to find 3/4 of 420, we take our 420 and divide it by 4, and that's equal to 105. Then 105 times 3, that would be 3/4, which is 315. So that's 315 litres, and that's it. Okay, let's look at our next question, question number 12. Okay, so question number 12, we're told that 3 identical gold bars are placed on a set of scales. So these 3 gold bars are identical and they're placed on the scales. And we've got the scale here in kilograms, and it goes from 0 to 4, and the arrow or the needle is pointing at this value here. And we've been asked to work out the mass of 1 gold bar, and we've been asked to include units. Okay, so let's work out the mass of the 3 gold bars. So let's have a look and see what this number would be. If we look at the scale, it's not going up in 0.1s because there'll be 0.1, 0.2, 0.3, 0.4, 0.5. So let's try 0.2s. So 0.2, 0.4, 0.6, 0.8, 1. So each of these little lines is 0.2. So that would be 2. 2.2, 2.4, so that's 2.4 kilograms. So that's the mass of the 3 identical gold bars. We want to find the mass of one of them, so we now need to divide that by 3 because there's 3 of them. So if we take our 2.4 and divide that by 3, we could do it in kilograms like this, and I'll do it in grams in a minute as well. So how many 3's go into 2? 0 remainder 2. And how many 3's go into 24? That would be 8. So that would be 0.8 kilograms. That's the mass of 1 gold bar. 0.8, 0.8, and 0.8. And if you have 3 0.8s together, you get 2.4. So that's one way, and that's one answer, 0.8 kilograms, 0.8 kilograms. Alternatively, we could work in grams. Whenever we read this to be 2.4 kilograms, we could say that's 2,400 grams, and then we could just divide it by 3. And how many 3's go into 2? 0 remainder 2. How many 3's go into 24? That's 8. How many 3's go into 0? That's 0. And how many 3's go into 0? That's 0. So that's 800 grams. So that's it. So each of those gold bars has a mass of 0.8 kilograms or 800 grams. And that's it. So let's write that down. 0.8 kilograms or 800 grams. And that's it. Okay, let's look at our next question. Okay, so question number 13. So question number 13 is our last question. And we're told shown below is the fuel tank gauge for a car. So this is the fuel tank gauge for a car. And we've got 0 or empty and full. And we're told that there's currently 51 litres of fuel in the tank. So this measurement here, this is 51 litres. So that means actually we can work out how much fuel will be in the tank, because we could divide the 51 by 3 to see what each of these sections is worth, and that would be 51 divided by 3. It's a calculator question. You'll get 17. That's 17 litres, that's 17 litres, and that's 17 litres, and then that would be 17, and that would be 17, and then you can work out how many litres would be in the whole tank. But if we actually carry on with the question, we're told that Benny says that the car will drive 7 miles per litre of fuel. And then part A says, work out how far the car should travel whenever it's got a full tank of fuel. Okay, so Benny says that the car will travel 7 miles per litre. And we want to work out how far the car should be able to travel when it's got a full tank of fuel. So let's work out how many litres would be in a full tank. So if we take the 51 and divide that by 3, that would be equal to 17. And I'm dividing it by 3 because, as you can see here, we've got 3/5. So if we divide it by 3, we can work out how many litres is in each fifth. So that's 17. So that means that's 17 litres, that's 17, that's 17, and so on. Then if we take the 17 and multiply that by 5, that's equal to 85. So that means the whole car holds 85 litres. And you can check that. If you take 85 and work out 3/5 of it, divide by the bottom and times by the top, you'll get that's equal to 51. And that's perfect. So that means the whole fuel tank will hold 85 litres of fuel. And we're told that the car should be able to drive 7 miles per litre. So if we take the 85 litres and multiply that by 7, that'll tell us how many miles the car should be able to drive. So let's do that. And when we do 85 multiplied by 7, that's equal to 595. So that means the car should be able to drive 595 miles. 595 miles, because for every single litre it should be able to drive 7 miles. So 85 times 7 is 595 miles altogether. And then if we scroll on down, we're told the car can actually drive more than 7 miles per litre of fuel. So Benny was wrong, it's not 7 miles, it's actually more than 7 miles. And part B says, how will that affect your answer to part A? Well, if it can drive more than 7 miles, rather than doing 85 times 7, we're going to do 85 times a bigger number, maybe 8 miles per litre, or 10 miles per litre, or 7.1 miles per litre. But what that will mean is that we're going to get a bigger answer. So the car's going to be able to drive more than 595 miles. So how would that affect your answer to part A? Well, it's going to increase it. So let's write that down. And that's it. I've just written down it increases, because if the car can drive more than 7 miles per litre, it'll be able to drive more than 595 miles with a full tank. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on reading scales. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you need any extra help on reading skills, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 284, there's a dedicated video tutorial there on reading skills. And that's it. So again, I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you found the Corbettmaths resources useful, the revision cards or the books or the video tutorials or the worksheets and so on, please share them with your teacher or a friend and tell them about Corbettmaths. That'd be really useful as well. Thanks very much. Cheers. Bye.